Okay, well, today we're going to be talking about section 4.3, which is indeed the slope-intercept form for the equation of a line. And so let's look at this in detail. So this says slope and it says intercept. When they say slope, they mean the numerical value of the slope, and the intercept is implied to be the y-intercept. And so as we're doing this, we're saying the slope intercept form, well, that would be an R. The form would be the equation of a line, and it takes the format y equals mx plus b. So if you have the equation of a line, one form it can take is called y equals mx plus b, which is the slope-intercept form. Why do they call it that? It's because this is the slope, and this is the y-intercept. You can clearly see both numerical values when we are looking at the equation of a line in slope-intercept form. There are two other forms that we're going to do. One is called standard form, and that's when it's ax plus by equals c. And there's another thing called point slope form. And they just have taken the original equation and solved it into different formats. So you do y minus y1 equals m, x minus x1. So these are the three primary forms for the equation of a line. And so standard form, slope-intercept form, and point slope form. And we will use all three of those this year. The question is, when is best to use which one? Well, I'll kind of work with you on that. I will work with you on that to help you know which one is the best. So where m is the slope and b is the y-intercept. Okay, so we have spoken already. If the value of slope is greater than 0, that means it's positive, okay? If you think about it, what numbers are greater than 0? The ones that are positive. And so if it is a positive slope, that means it's going to be going uphill from left to right, okay? If it is negative, less than 0 means that it is negative. Okay, and so that would be going downhill, and that would be a hill that goes downhill from left to right is negative. Numerically, we talked about this the other day. If it is horizontal, doesn't go up or doesn't go down, it is numerically 0. And then the most steep line you can have is vertical, and that would be when the slope is undefined. It is nearly infinitely steep. It is infinitely steep. And so how you talk about that numerically is that is undefined. Numerically, actually, if you go from one point to the next, it's like you're going up a bunch. Okay, you could be going up a couple, but you go left and right, nothing. And if you divide those two numbers, you get an undefined value, and that's how they come up with this right here. So no matter how much you go up or down, you never go right or left. So your denominator is 0. So rise over run is something over 0 because you're not traveling left or right ever. And so that is the numbers as to why it is undefined. Okay, when we go to graph lines, okay, there's a specific way that you can do it. One way to do it is to start by graphing the y-intercept. The y-intercept is the distance that the first point is above or below the origin. Okay, on the y-axis, how much above or below the origin is your first point that you end up graphing? And the slope and the y-intercept are called parameters. We're not going to make a big deal about that. Those are going to be changing the location of the line and also the steepness. Okay, the slope changes the steepness, and the b value, the y-intercept, it changes its height. Where do you start when you start graphing our lines? So the next thing we'll say is we have a constant function. Takes the form of y equals a number. So if you had like y equals 3, the example we've spoken of before is when y is always 3, no matter what you plug in for x, the result is consistent, okay? And it always gives you the value of 3. So a constant would be when you're graphing a horizontal line, when the y-coordinate has a constant result, okay? The consistent result. The slope of a horizontal line if you graph this line, y equals 3, will be contain at least these 3 points and a lot of other ones. The slope of that kind of graph is 0. It's not going up or down. And it intercepts the y-axis at that point, okay, at this value right here at 3. And it will be above or below the x-axis, which is pretty much implied, as long as it's not y equals 0. So it'll be a horizontal line is the main thing you need to hold on to. Another name we can call a horizontal line is a constant because it has a constant result, no matter what you plug into it. On the other hand, okay, so that's y equals number. On the other hand, if you have a vertical graph, okay, so that was a horizontal graph. A vertical graph is going to be x equals a number. Okay, and so if you do x equals a number, it has an undefined slope, and we spoke about this before, and that would be if you have like x equals, say, 2. That means if you make a table, x is always 2, y is whatever you choose, and that will be, if you plot these points, you're going to get these 3 here. So it'll be a vertical line at 2. And so the vertical lines are going to be undefined slope, like the most severe slope you could ever have, the steepest hill you would ever think about climbing, and then also it's a vertical line. So x equals a number will give you vertical lines, and we've spoken about that before. There are 2 acronyms you can use when we're talking about vertical and horizontal lines. One thing you should know is that if you've got a slanty line, you know, it's going to look like y equals mx plus b, like y equals 2x plus 3. So if an equation has both x and y in it, it is going to make a slanty line. Okay, slanting uphill or slanting downhill, depending on the value of the slope. If, however, it's just x equals a number or y equals a number, it'll be a horizontal line or a vertical line, depending is it x equals or y equals. So if you have HOI, okay, this is an acronym to try to help you remember. If you want to use it, great. If you don't want, if you want to just figure it out each time, that's fine too. A horizontal line. I used to always struggle with, like, what's a horizontal line? A horizontal line is like the horizon. You know, if you look at the sunset, it's a sun peak. Oh, that's a green sun. Let's hold off on the green sun. I was trying to make it orange. If you've got a horizon, the sun setting, okay, the horizon goes left and right. Okay, that's the horizon. And so a horizontal line that goes left and right, it has a 0 slope. And it's y equals a number. So if you've got like y equals 3, you know when you make a table, no matter what you plug in for x, the answer is always 3. And that will be a line that's horizontal at 3. Slope is 0, and it's y equals a number. It's going to be the equation. For Vux, a vertical line, okay, you can put your arms up straight. You can imagine, you know, a little guy standing here with your arms standing up straight. Oh, there's my hands. Oh, I made funny hands. Oh, there we go, cheerleader. Hands up straight. The truth is a vertical line is going to be, oh, he has several sets of hands. That is just quite a drawing. Why don't we try it again? Here's your person. His arms are up straight. Okay, so a vertical line is going to be vertical, like up and down, okay? Like a V for vertical. So a vertical line has an undefined slope, and it's x equals a number. So if you had like x equals 2, you know that the table says x is 2, y is whatever you want it to be. And so when you plot these points, you're going to get a vertical line at x equals 2. Okay, so the slope is the most infinite slope, so we call it undefined. Because no matter how much up or down you go, you never go left or right. So your rise over run would be a number over 0, which would never, is the numerical value of that is undefined. So the next thing we're going to do is we're going to write equations in slope-intercept form. Well, first of all, what is slope-intercept form? Slope-intercept form is y equals mx plus b, where this is the slope and this is the y-intercept. Okay, so to write this equation, we're going to do that's the slope right here, and this is the y-intercept. So y equals, we know the slope, and we write the y-intercept. Okay, so just plugging in those values to the locations in the equation. And so if the slope is -5, you would write y equals -5x, and then -12. The y-intercept is at -12. The slope of 0 and the y-intercept is 6 would be y equals 0x minus 6. Technically, a slope of 0 will always reduce to 0 times x is 0, so y is equal to 0 minus 6, or y equals -6. This coincides with our belief that a horizontal line has a slope numerically of 0, and it just goes from left to right, so it's at -6. So that's what that graph would look like. If your slope is undefined and your x-intercept is at 3, you can imagine this is x equals 3. Any vertical line is just x equals, any horizontal line is just y equals. And so holding on to that, learning that, practicing that, rehearsing that is going to be good for you. Okay, let's keep trucking. Now, the deal is we are going to work on, if you look ahead, we're going to practice graphing these lines. And the way that's easiest to graph them is if you know the slope and the y-intercept. So the format that's easiest to graph from is going to be if you know the slope and you know the y-intercept. And so getting a slope-intercept form would be good. So slope-intercept form is solve for y. And you put the x term first and then the y-intercept second. So to solve this for y, we've worked on this a little bit. We want to isolate the y term. Okay, so that doesn't mean get rid of the 4 first. That means move this 16x term to the other side by minusing it. Why do we minus it? Because it's plus. So you've got -4y equals -16x minus 56. Put the x term first and then the number term. And then to get y by itself, we're going to divide everybody by -4. And you're going to get y equals -16 divided by -4 is 4x. 56 divided by 4 is going to be 14. And negative over negative is positive. This is our equation. And you can see that the slope equals 4 and the y-intercept equals 14. Okay, solving this for y, you're going to add 12x to both sides. Always put the x term in front of the y term, or the number term. Now we'll divide everybody by 8. And we can reduce this fraction. Never make it a decimal, never make it a mixed number, always make it a fraction, whether it's proper or improper. Leave it as a fraction. So if you have 12 over 8, you can divide it by 4, and you get 3 halves. So it'd be 3 halves x, and then plus 3. The slope is equal to 3 halves, and the y-intercept equals 3. Now we're supposed to write a linear equation with the center. There's not a lot of space in here, but it says in 2012, there were 183 million social media users. So at this point, okay, we have, I'm curious about this one here. Okay, at this point, let's rewind this a second. What does it say? The number increased every year is 9 million every year. Okay, we don't need to do 2 points. Okay, we don't even think about that. What we can think about is how many users are there? Well, it starts with 183. And there's 9 million more every single year. So the rate that it's growing by is by 9 every year. So 9x plus 183. So you start with 183, that's your beginning value. That's the y-intercept. And your rate of changing is 9 million every year. X equals the number of years since 2012. Okay. And we could be like, okay, well, in 2015, how many were there? Well, you could plug in, that would be 3. So you could plug in X is 3 and figure out how many users there would be. The next thing we're going to do is we're going to graph. Okay, so using y equals mx plus b, step one is get it into slope-intercept form, solve for y. Okay, step two is going to be, can you graph the y-intercept above or below the origin on the y-axis? Okay, that's going to be this value right here. And then the third thing is, let's take the slope, okay, and let's graph it from that point. So if you've got a positive slope, so that's this value right here. So if you have a positive slope, it's going to be, the fraction will be up and right. If it's negative, it's going to be down and right. And so you have to look and say, what is that slope? Is it going to go up and right or down and right? Okay, so let's look at this. Our first graph says, graph the line who has a slope of -3/2 and a y-intercept of 4. So we don't have the equation, we could write it. So y equals -3/2 x plus 4. It says the y-intercept is at 4. So from the origin on the y-axis, you're going to go up or down the value of the y-intercept. So the y-intercept's at 4. So we're going to start here. And your slope says do -3/2. So to do that, we're going to do negative slopes imply that you go the numerator down and the denominator to the right. So that means 3 down and 2 right. So we're going to go from here, go down 1, 2, 3, and right 2. And down 1, 2, 3, right 2. And that's going to be our graph. You need to put arrows on it because we don't want to graph the whole thing. And we do want to make sure that we use a ruler when we're on paper. I'm using this projection. I don't have a ruler that works. I cannot figure out how to do this ruler right here. So we're going to just say, pretend I got a ruler. Now, the thing is that it probably is good to practice doing a couple more points than what we have here. So let's see if I can add a couple more points. Okay, so we're going to go 3 down. We got to pretty much fill the graph. Let's go down 3. 1, 2, 3 over 2. And you can go up 3 and left 2. Okay, you need to have at least 5 points if it fits. Okay, so let's do 5 points. Ruler and arrows. Okay, I think I got a mistake, so I'm going to pause you guys. Sure did. All right, so back to you guys. Here we go. Let's get this in slope-intercept form. So that's -12x from both sides. And you get -3y equals -12x plus 18. We have to solve for y, so divide by -3. Get y equals 4x minus 6. And if you've got negative or negative, it makes positive. If you've got positive and negative together on a fraction, it makes negative. And then you just reduce or divide them as appropriate. Always leave your slope either as a fraction or whether it's proper or improper. So we can write 4 as a fraction as 4 over 1. Any number can be written as a fraction by putting it over 1. So we're going to start at the y-intercept. Y-intercept is at -6. So from the origin, we're going to go down 6. Our slope is 4. So if the slope is 4 over 1, that's 4 right, 4 up, sorry, and 1 right. So it's either up and right or down and right. And so we're going to go up and right. It's a nice looking up. Just kidding. That's better. So from here, we're going to go up 4. 1, 2, 3. So to go up, you know, one thing I didn't say is you don't count the point you start on. You go up a point. Like if you're going to measure your steps, like in the front of the room, you know how you count. You don't count where you are. You count your first step you take. So this would be your first step, second step, third step, fourth step, fifth step. Wait, we have to go 4, not 5. And then over 1. Okay. And then we could do it again. 1, 2, 4, and then over 1. And then you go up 1, 2, 3, 4, and over 1. And we're supposed to do about 5, okay, if it'll fit. And so, oops. You go down and you could connect these with your ruler and put arrows on it. All right, good job. The last one we're going to do on this line right here, forget if there's more past it. Oh, we got a whole 3 more. This is already solved for y, and the number in front of the x is a 1. It's a -1. So you can put it there. So the y-intercept is at 0. Okay, there's not a number added here. And your slope is -1. So -1 over 1, okay, put over 1 to make your slope, tells you to go 1 down and 1 right from the start. So you're from the start, the origin at 0. You're going to go down 1 and right 1, down 1 and right 1, down 1 and right 1. You need at least 5 points. Connect the dots, put arrows on it, call it a day. And then the next 3. Okay, here we go. And we're going to do a word problem. The next 3, the first one has a slope of this, of a half, and the y-intercept here. We start by graphing the y-intercept at -7. So 1, 2, 4, 5, 6, 7. Your slope is a half, it's positive. So it's up and right. So from here, you're going to go up 1 and right 2, up 1 and right 2, up 1 and right 2. You need at least 5 points if they'll fit. There you go. Y equals 2. It's going to be a vertical horizontal line. The y value is always 2. The x coordinate is anything you want. It's going to be, if you plot these points, it is going to be this line right here. Okay, y equals 2. And it's going to touch the y-axis at 2. It also is horizontal lines have 0 slope, and they're y equals. So if you remember it, you don't have to make a table unless I ask you to. This one says x is always -5, and y is whatever you want it to be. So if you plot these points, you go to -5, 1, and 2, and 3, and this will be my equation. Okay, y equals -5. All right, the word problem. Suppose that gas costs $2.50 every gallon, and you purchase the car wash for $5. So you're going to pay $5 for that, and write an equation talking about the cost of purchasing a car wash and a certain number of gallons of gas. So your cost, okay, is y equals, okay, you're going to do $2.50 every gallon, and you're going to add on to it $5 for the car wash. And so this is gas. So the y equals the cost, x equals gallons of gas. And then we can graph this, okay? So let's do this. If you buy 0 gallons of gas, but then you would do 2.5 times 0 and add 5. That would be 0 plus 5 or 5. If you buy 1 gallon of gas, it's going to be 250 times 1, so that'd be 750. And they said skip ahead and do 8. Okay, so 250 times 8 and add 5. And that is going to be, let's see, 5, 15, 20, that's 20 for this, and add 5. That'd be $25. So we can graph this. 0 is $5. 1 would be $7.50. And if you did 8, it would be $25. You can get out your ruler. And that would be my graph. So depending on how many gallons of gas you buy, it's going to be increasing in cost. So the beginning value or the y-intercept's at 5, and it's going to increase to 50 every time you buy another gallon of gas. And it does make sense to connect these because you can buy partial gallons of gas. You can buy 1.5, 1 3/4, lots of decimals when you buy gas. It's not normally an even gallon amount, unless you're completely empty or you're fixated on whole numbers. The last couple, I'm going to ask you guys to write the equation of these lines. And so to write it, you're going to use slope-intercept form, which is y equals mx plus b, unless it's vertical or horizontal, okay? And so on this first one, the y-intercept is at 2, okay? So b equals 2. And then to calculate the slope, we've got to figure out what is the slope between 2 points. So we look at our graph, and we have to find 2 points where we can kind of calculate what slope does this graph have. And this slope has, those are 2 nice points here. This is 1 and this is 2. And it's going downhill. And it's rise over run. So this would be the rise. This is the run. So it'd be negative a half. So our equation would be y equals negative 1/2 x plus 2. On this one, my y-intercept is going to be at negative 1. And to find the slope, we're going to find two nice points. There's 2 here, 3 below here. So to count the slope, you count the boxes outside of the triangle that you find for slope. So your slope is equal to 2/3. So y equals 2/3 x minus 1. So you just have to pick two nice points and calculate the slope, the rise over the run. This right here is going to be a horizontal line, and it touches the y-axis at negative 2, so it'd be y equals negative 2. So right here is a vertical line. It touches the x-axis at 6. This would be x equals 6. All right, well, that is what I have for you today. You definitely need to practice it. Have a good day.